Well, how are you doing? Okay, this is the fourth video I've had to make on this issue. The first two, I used LIGO, the Hanford LIGO station, as a right angle, because they can't argue that that's a right angle, right? And straight lines. Um, the third one, which was yesterday, before this video, I used distances across Britain, right? From London, Birmingham, places like that. Now, all of our opposition, Charles Flat Earth Math, Blue Marble Science, and a whole host of other bozos keep saying you need to make the distances bigger because the distances are so small that it could be a spherical triangle, blah blah blah. It's like no, right? You don't understand, right? You can't do trigonometry, which I'm showing is being done, right? And correctly with getting the correct distances on the surface of a sphere with a spherical triangle. Trigonometry requires there to be no more or no less than 180 degrees. That's what is necessary to do it. So what they wanted, see, they thought, because they always think that we're stupid. They always think this, right? No matter what you do, they always think that somehow they're smarter in some way. I don't know why this happens with them because we keep on destroying them. So if we're so stupid, how stupid are they? Because we keep winning. You know, we don't lose. We keep destroying them, keep beating them. We beat them all the time for the past 8, 9 years. We beat them time after time after time after time. They never win. Yet they still think that we're stupid. So if we're so stupid, then how stupid are they? You know what I mean? No, that's a concept they wouldn't have thought of because they're stupid. But anyway, this is the thing, right? This here, they think that by me showing this is some kind of a win for them because Google Earth, right, will show these two curved lines, right? But what they're forgetting is this here is an exact right triangle, right? I've used the headings to get an exact right triangle. And that can't happen on a globe. There is no such thing as an exact right triangle on a globe. An exact right angle, on a globe. You can't have that, right? It can't happen on the surface of a sphere. It can only be a chord, right? Chord lengths. So these three lines can only be chord lengths on the globe Earth. Yet I know that this line here, right, and which is the opposite, and this line here, which would be the base if it was the other way around, right, are correct distances across the United States. This is I start in at the Lumen Stadium in Seattle. Let's just show um, the Lumen Field in Seattle, which is obviously a sports stadium, and I go from there over to the memorial, the 9/11 memorial here, 9/11 memorial. That's where I go to. There's a car just outside that, the 9/11 memorial, right? And they are correct distances across the United States because you can use Google Earth distances, right? So these distances are from Lumen Field down to Southern California, or Northern California, or somewhere in California, right, near Lompoc, um, and across then to back to New York as the hypotenuse. So they think that by me showing this curved triangle here, like curved lines thing, that's some kind of a win for them. They're not understanding. No, Google Earth will try and show you that, but it's all the distances, everything is being calculated, right, with 180 degrees. That means they're calculating it like a map, a flat map, and giving you the correct distances. So I'm just going to go through the details. So line A, right, is a heading of 83.18 degrees. This is from Seattle over to New York. It's 2,408.01 miles. Line B is 173.18 degrees heading, and that is from Seattle down to just north of Los Angeles. That's 906.85 miles, right? The polygon length of them, I'm just going to show, just so you can, just so there's no argument. Where's the polygon, right? There's the polygon length, right? So you can see it. I only have the one length here. I don't have that length in, but I've just shown you where the length it is because I can only save one at a time. I can only show one at a time with the line. So there's the polygon length. Let's read it out here. It's 5,867.68 miles. So if I add these two numbers here together, line A and line B lengths together, right, which is 2408.01 plus 906.85, I get 3,314.86 miles. Then if I take 5,867.68 mile, my polygon length, mile around perimeter polygon length, and I subtract 3,314.86 miles, I get I get a hypotenuse length of 2,552.82, right? That's what I get, miles. Right? So 2,552.82 miles. That's what I get. So if I 906.85, just gonna write that down. So 1 second now. So 906.85. Okay. So if I just go to Google a second, I have my first 2408.01, just to confirm, 2408.01, my first length into the triangle calculator. Now I'll put my second length, which is 906.85, right? And that gives me 2,573. So my calculation was slightly out by where are we? 2552. So mine is 2552, and that one is 2573. So I was out by a little bit because this is the right triangle calculator is more precise, obviously, right? It's calculated more correctly, right? So 2573 miles. So that means that what that means is, right, that this is all horizontal lines and horizontal distances. None of these are chord lengths. None of them are chord lengths. So, and to prove that, I'm just going to show. So, right, my calculation was 2552, right, 0.89. So I have 2552.9, right. That would be the arc length, right. So that would mean the chord length through that, right. Even though mine was should have been 257. What was it? 2573. Right, let's just try and do it to 2573. Right, so almost there, a bit over. Let's try and get it right. Now, 2573. Right, make sure that's correct with this. 2573. Right, so that's what it would be. Right, that's the correct one. So the problem is, this is the same problem each time, right, for the globe, is that if, I'm just going to show, right, if that is over the surface of a spherical earth, then these lines, right, must be chord lines, which means they must be less in length than the arc length that's above them, which means that this one here, this line here, right, this hypotenuse line here, this has to be, right, 2,528 miles, 0.5 miles. But it's actually 2,573. So let's check the difference, right? So it's going to, right, so 2573, right, minus 2528, 2528 equals 45. So just that one hypotenuse length alone is 45 miles, right? That would be, that one chord length here would be, if what I was showing on Google Earth was over the curved surface of a globe Earth with a radius of 3959 miles, then this chord length here would be 45 miles shorter than the arc length that's above it. That's 45 miles, right? You can't mess with that. And the same for the other two. They're going to be less in length. But that's not what we see. This is, it doesn't matter what way Google Earth try and portray it on the screen, they have to calculate it correctly, and the only way to calculate it correctly is through planar trigonometry. And that means planar trigonometry is giving us correct distances across all landmasses. Right? Which means that, and the reason it is because it's using 180 degrees within a triangle. Because you can't do trigonometry with less or more than 180 degrees. It doesn't work. That's how it works. Triangles, 180 degrees. So, sorry, 180 degrees. So I'm trying to tell you that they can do trigonometry, right, with more or less than 180 degrees, are either crazy or liars. That's the only way. That's all there is to it. You can't do it any other way. So these lines appearing curved means absolutely nothing. If the globe side want to see that as some kind of a win, that Google Earth tries to show curved lines, when I'm showing that it has to calculate everything in planar trigonometry, showing that horizontal distances, right, the distances across the surface of the Earth are all horizontal. Google Earth has to use flat distances. There's no chord line lengths. There's no chord lengths here. That's all surface distances. So there's no way out of this. There's no way out of it. 45 miles. That's 45 miles. That would mean if you were going at 45 miles an hour, it would take an hour to drive that extra distance. Think of it that way. If you were traveling at 45 miles an hour, it would take you 1 hour of driving to cover that extra distance. If this was a reality, but it's not, obviously. So there's no way back out of this. There's no way out of this for them. They want to keep on looking for stupid nonsense. Well, there you go. How do you make up the 45 miles? You don't. And that's only in that one line. There's also this line here, right, and this opposite line here. There's the baseline or roof here for the moment, and the opposite line there. And what about all the other lines that you can make here? What about all them? Because it's not just one line with a 45-mile difference. It's every line in every direction across the surface of the United States here. Every single one, no matter what direction you go, will all have discrepancies for the globe. They'll all fit flat, and they'll all have to be calculated and measured flat with planar trigonometry. There is no other trigonometry. Spherical trigonometry is just a mathematical back calculation using triangles from a center point of a pre-assumed mathematical globe. That's all spherical trigonometry is. It can't be done without using actual triangles from a center point. I've been saying this, I'm blue in the face saying this for years. Yet our opposition just don't seem to want to understand that. They don't understand it. Here you go. There is a planar triangle, 180 degrees, on the surface of your claimed sphere, giving us exact distances. What are you going to say about that? You have nothing to say. It's over. There's no way around it. There's no point. You can't throw Google Earth under the bus. You can't do that. Its distances are used all the time correctly. How do you make up 45 miles? You don't. Because I can change this triangle to a different direction, and there'll be lots of discrepancies there. Every time I do this, there's nothing but globe discrepancies. And as usual with these people, they wouldn't stop pushing it until they get absolutely annihilated, which happens every time. They think that was going to be some kind of a win for them. Are they stupid? Seems to be. I don't know how this is a win. How is this a win for you? No win here, not for you. Thanks for watching.